In this lesson, we're going to be looking at choosing an instrument. And by the end of it, you should be able to understand a little bit more about sensitivity, range, precision, and accuracy when you're talking about taking readings or using instruments. So whenever you're using instruments, the first thing that you have to do is choose the correct instrument for whatever quantities that you're going to measure. And a couple of questions that you could ask yourself is how quickly you want the instrument to respond. What are the limits of the readings that you're going to be taking? Can the instruments measure the values that you're expecting? And how precise you want the readings to be? The first question, when you try to answer it, is more how quickly sensitivity. It deals with sensitivity. It is a matter of how quickly the instrument would actually respond to changes in the quantity that's being measured. If you have an experiment that requires you to take readings every minute, you may not need such a sensitive instrument, as compared to if you need to take readings every 10 seconds. The instrument needs to be very sensitive in that case so that it responds very quickly to the changes that occur. When you're answering question number 2, it deals with the range that your instrument is capable of measuring. And the range just simply talks about what is the maximum value on the scale and what is the minimum value on the scale. For instance, I am not going to take a mercury glass thermometer and go inside of a kiln to measure temperature. Nor am I going to actually take a 6-inch ruler and try to measure the dimensions of a house. It simply is not feasible because the ranges of these devices are not capable of measuring the quantities that you have. When you're dealing with the third question, it matters about the third question. It deals with accuracy. And the accuracy of the instrument is how close you can actually get to the true reading. Say for instance, the true reading has an answer to 3 decimal places and your instrument can only give you an answer to 1 decimal place. Then your reading may not actually be accurate. And let's see if we could actually put this into a graph form. Say for instance, you have a graph here and this is where your true value lies, right? At value of t0. And this is where your reading value lies. Let's say somebody else is doing the same exact experiment and their true value lies here in the same place and their readings lies right here. Right? Now when you compare these two sets of readings, you will see that one of them is much closer to the true value that you expect, which is this one. Right? This reading would tend to be the more accurate one, whereas this one here would tend to be the less accurate. And the reason that you can see that is that the distance between the readings that they did and the true value that you expect is much larger than this here. If you were to find the difference, t minus t0, it would be larger here and smaller here. Alright? When you're dealing with the fourth question, we are dealing with the precision of the reading. How precise do you want the reading to be? Again, in the situation where you're required to measure 3 decimal places, you would want your instrument to produce a result that has 3 decimal places. If it is that your result is 2 decimal places, you would also require the instrument to produce a result that is at least 2 decimal places. And if we were to also draw this onto a graph, we can see what precision is about. Let's say for instance we have 2 people doing the exact same experiment. However, all the readings that were obtained tend to have this kind of distribution about a value here. Alright, let's call this value the average value, and I'm going to still use the t0. Alright, let's say for instance the other person here does the same experiment and their distribution of results tend to look like this. Now you can see right away that these values here distribute over a larger area, and that the average value that it would obtain would not be close to this. It may be, but it may not be a very precise reading because the range, the error, the allowance for error is very large. If we look at the next reading from the other group, we would see that their values tend to work about a central value here for the true value or the average value. And you can see that deviation in their average tends to be much smaller than the previous group. So this group here would have information that is less precise, whereas this group here would have information that is more precise. Now, when you talk about a result being either precise and accurate or not precise and accurate, you just simply merge the two of them together. For example, if I have this kind of graph here and I am saying that this is the results, this is the distribution of the results, and this is where the expected value is, I can say that this here is a value, this set of readings is very precise because the deviation with their average is very small. But it is not very accurate because the distance from the true value is much more. Alright? Say for instance we have something that peaks like this and the true value is right along the center here, like this. We can say that this is both accurate and precise because the distribution of the value is very small and the average of this distribution is very close to the true value. So it's both accurate and precise. Alright, so you simply just have to watch the data and be able to tell whether information is either precise or accurate or both or one of them. And if it is that you're choosing an instrument, you have to consider your max and min values and how quickly you would like these values to, how quickly you would like the instrument to actually respond. So if you have any questions or comments or anything was unclear, you can send me a message or leave a comment with the video below. Thank you.